Hi, I am Abhishek Choudhary, working for iSecure Private Limited. In this presentation, we will discuss on design pattern. Our agenda is what is design pattern, why design pattern, types of design pattern, how to implement the design pattern. Let us start with the what is design pattern. Design patterns are solutions for most commonly and frequently occurred problems while designing a software. Design patterns are formalized best practices that the programmer can use to solve common problems when designing an application. Design pattern can speed up the development process by providing tested, proven development paradigm. Reusing design patterns helps to prevent shuttle issues that can cause major problems, and it also improves code readability for coders and architects who are familiar with this design pattern. So, with the help of design pattern, we can avoid multiple problems. Based on problem, the design pattern divided into three categories. First one, creational design pattern. Second one, structural design pattern. Third one, behavioral design pattern. Let's start with the creational design pattern. In this category of design pattern, we will discuss about the problems related to the object creation and their solutions. Types of creational design pattern. In this category of design pattern, we will discuss about the different problems related to the object creation. Means when we want to instantiate a single class, in some cases we have to call multiple methods to instantiate a single class. In some cases we have to create the multiple object to instantiate a particular class. In this design pattern, we will discuss about how to avoid that problems and what is the best solution of all those problems. So, creational design patterns divided into 7 categories. These are Singleton, Factory, Abstract Factory, Factory Method, Prototype, Builder, and Object Pool. Singleton design pattern. Singleton design pattern is used when we want to instantiate a particular class only one time and we want to use that instance multiple times. In that case, we will use this Singleton design pattern. To develop Singleton design pattern, we have to follow some rules. First one, we have to make a class constructor as a private, and we have to create one method. That method must return the object of that class, and it should be asynchronized. With the help of these two rules, we can make a class as a singleton, and we will apply some conditions, like if that class is already instantiated, in that case we will not execute the instantiation logic. If it is not executed, in that case we will execute that process. Suppose we want to create a class like database property we want to use in a project in multiple times, but all the property of database should be same in all the places. So we can make a class as a singleton, and we will use that object in different places for different purpose. There are many other examples of singleton classes. Factory design pattern. When we want to hide the object creation process from user, in that case we use this design pattern. For example, in case of JDBC, there is a connection interface. We want to get the reference of connection interface implementation class. So we are just calling the driver manager class method get connection, and we are getting the reference of connection interface. In that case, we don't know how we are getting this reference and how internally it's creating the object. For example, clients need object of product interface. It will call the implementation class of product IMPL, and it will call the factory method to get the object, and factory method will return the object to the client. Factory method design pattern. Before starting with this design pattern, we have to understand what is factory method. A method which returns object of a class is called as factory method. So factory method design pattern is used when object creation process is complicated. Means sometime object creation process is complicated, we have to write some lines of code to create a single object. In that case, we will refer this design pattern and will write the object creation process inside one method, and we will call that method whenever we want to get that particular object. For example, a client needs an object of implementation class of interface product, so it will call the factory method. This factory method internally creates a object, and through the another factory
and it will return to the client.
Abstract factory method design pattern. In abstract factory method design pattern, we will discuss about how to implement factory on factories. Means we have requirement like we want to call factory on another factories. In that case, we will refer this design pattern. The example of this design pattern, XML API implementation. Abstract factory will call first document builder factory, and again it will call the document builder. Means we have to call the two factory method to get the object of document. So we can say that it's a factory on factories. Like scenario is client need a object of implementation class of interface called product, so it will call the factory method, and this factory method internally call the another factory method, and it will create the object and will return to the client. Prototype design pattern. When object creation process is costly and time taking, in that case we will use this design pattern. In case of prototype design pattern, we will create one copy of object and clone the object. Cloning means creation of another copy of object, of real object. There are two types of clone: shallow copy and deep copy. Shallow copy only copy the primitive data types of particular class, and in deep copy it will copy all the primitive data as well as reference data. Reference data means a data which is a type of object, like class type of data. For example, if we have a interface, client needs a implementation class of that interface. In that case, we will implement the interface all those properties as a shallow copy or as a deep copy. Whenever we want that shallow copy, we will call that shallow copy implementation, or we can call as a deep copy implementation.
Builder design pattern. Builder design pattern is used to separate the construction of a complex object from its representation, so that the same construction process can create different representation. For example, let us take the case of vehicle manufacturer. So in that case, from a different set of parts can build a car, bicycle, motorcycle, but in all the cases the procedure should be the same. So we will follow the same procedure to build all the different object. In that case, we will create a procedure of one object creation and will implement in another object. Suppose there is one client, and first it's created one object called field1, then another object field2, another object field3, and another object field4. These are the 4 sub-objects. Then it's combined and created the another object, which is the main object. So here we are following the construction process to build the multiple object. Object pool design pattern. Basically, we will use an object pool whenever there are several clients who need the same resources, which is expensive to create, and client make a request for an object on a reusable pool, and it will get returned back from that reusable pool a object. After using that object, client need to return that object into the pool so that others can also use the same object. In case of JDBC programming, we are creating the connection pool. From that connection pool, we are using the object, and then after using it, we are returning back to the connection pool. For example, client needs a object, it will request to the reusable pool for reusable object, it will use it and will return back to the pool. A structural design pattern. Let's start with the discussion on a structural design pattern. Here, a structural design pattern. In this category of design pattern, we will discuss about the object created inside the another object. Means we will create some relationship between objects. So there are different category of this design pattern. Those subcategories are adapter, bridge, composite, decorator, flyweight, and proxy. So with the help of these all the category, we will remove the problems related to the object created inside the another object, means object relationship problem. Adapter design pattern. In this design pattern, we will discuss about how two incompatible interfaces to work together. Adapter design pattern is used when we want two different classes with incompatible interfaces to work together. In that case, we will implement this design pattern. Adapter design pattern can be implemented in two ways. One, by using the inheritance method, and by using the composition method. The difference is implementation methodology, but the purpose and the solution are the same. In adapter design pattern, we will develop one type of adapter that is helpful and that can understand the both incompatible interfaces, and it will transfer the one request to another. For example, there is a Java application and here some databases. Now I want to send the data from this Java application to database. For sending the database implementation is different and Java application implementation is different, and both cannot understand each other. In that case, we need some type of adapter that can understand the Java language also as well as MySQL language also, so that it will take the data from the Java application and that can transfer the data to the database. For that, there is an adapter. So these adapters are MySQL JDBC driver, Oracle JDBC driver, and DB2 JDBC driver. So we will load this driver in our application and we can send the data through the drivers. So first our data will go to the driver. Driver will take the data and it will transfer the data to the appropriate database. Bridge design pattern. In this design pattern, we combine two different classes have same function but different implementation by providing a bridge between them in form of interface and their implementation. For example, if we have a vehicle class and in that vehicle class we have two different subclasses, car and bike, and it have a same method start and stop in both the classes but the different implementation. So it will avoided by implementing the bridge design pattern. Here I have created one bridge. So I will define the vehicle and function to interface, and inside the vehicle we will store car and bike, and function contains a start and stop method. So we can bind up the particular car with the function and bike with the function by providing the appropriate implementation. Composite design pattern. In this design pattern, we will discuss about the recursive structure, like a one structure contains the another structure. A structure Here combination of primitive type means, suppose a real-time example, like if I want to represent a building, in that case complete building is one structure, but it contains multiple rooms, and room is itself a structure, and in that room windows, doors represented as a primitive type. Means with the help of primitive data we will create the structure. Sometime with the help of primitive data and another structure we'll create one structure. Here a structure which have two substructure, and that is a combination of multiple primitive or primitive and a structure. Here and leaf must be always a primitive, it should not be the structure, because always a structure is created with the help of some primitive data. Decorator design pattern. This design pattern is used when we want to apply any functionality at the time of execution of project. In that case we will use this decorator design pattern. For example, if I want to generate a report in different format like PDF, docs and Excel, so according to our requirement this design pattern will generate the output. So there is a one component, and this component have one interface and their implementation. At the same time there is one decorator and their implementation. So according to our requirement it will get implemented. Flyweight design pattern. When the number of objects to be created by application should be huge, the object creation is heavy on memory and it can be time consuming. In that case we will implement the flyweight design pattern. Means when we are developing any project, in that project there are multiple classes, and in that classes some data are common for some classes. In that case we will develop a two type of classes, one for the common data and one for the uncommon data. We will keep the common data in one class and we will use that common data in multiple times. For example, class data have two types of data: common data, uncommon data. Common data we will keep in a interface and their implementation will use whenever we want this common data for multiple times.
Proxy design pattern. In proxy design pattern, we are creating the proxy object of a real object. In some cases, the object creation process is time taking, and at the same time, some data is required to create the object. In that case, we will use this design pattern. Here, proxy means it's not a real object, but it will act as a real object. For example, in case of ATM, we are not getting the exact banking services, but it will act as a banking services. So we can call as a ATM is the proxy of bank. Here one real object and have some proxy object. So account have both real and proxy. Branch also have the real and proxy. Means in proxy ATM system there exists some account related information and branch related information. At the same time, the data is exist at a real object. Same data populated to the proxy. But it is not the real object. It will act as a real and it will give the output like a real object. There are many more examples of proxy or design pattern. Let's start with the another category of design pattern, that is behavioral design pattern, which is related to the object communication process. Means in this category of design pattern we will discuss about the problems related to the object communication process and how to resolve that problems. Behavioral design pattern. In this category of design pattern, we will discuss about object communication. How one object will communicate to other object and the problems related to the communication between objects. In this category of design pattern, there are total 9 subcategories. These are chain of responsibility, command, interpreter, iterator, mediator, observer, strategy, template method, visitor, memento, null object. Chain of responsibility. In this design pattern, we will discuss about the object communication problem. One object wants to communicate to the other object, but the object which want to communicate don't know about the destination object. In that case, we will apply this design pattern. For example, when we are using the exception handling techniques, in that case, sometime we don't know which one exception will occur, whether a IO exception or the SQL exception. In that case, we will use this design pattern and will throw all the exceptions which is possible, and whenever the exception will occur, the desired exception will catch that request and it will handle. Like clients requested to the handler 1, handler 2, handler 3, handler 4. Means if handler 1 is not responding, in that case it will forward the request to the next handler, and whenever the object is caught, the process will stop.
Command design pattern. In this design pattern, we will discuss about how we can execute the multiple command by combining all those commands in a single object, so it will get executed according to the action. For example, we have a different command and there is a one command handler. It will get all the command in a object format and it will perform the required action according to the command. So we can take another example. In case of file system, if I want to provide the read, write and close operation to the file, in that case we have to create one command which can read and another for write and another one for close. Command handler will take the action according to the required operation. Interpreter design pattern. In this design pattern, we will convert the data defined in one language to the another language with the help of some grammar rule through the interpreter. In this design pattern, we will not get the complete solution of building a particular language. We can define only some rules and we can apply some grammar, and with the help of that we can create a part of language. We can take an example of regular expression and mathematical expression. Suppose we have a language which is generated by a Java compiler. Now, an interpreter JVM will take that and it will interpret into the another language by applying the interpreter design pattern. Iterator design pattern. This is the old design pattern. Now Java provides us a iterator interface and a list which contains a list iterator method. With the help of that, we can iterate the element. So in this design pattern, we are traversing the element, means there is a set of element. In that element, sometimes we want to traverse in previous direction, sometimes we want to traverse in next direction. In that case, we will use this design pattern. For example, there is a one collection and we want to iterate that. In that case, we have a two option, whether we can go in next or in previous direction. Mediator design pattern. In this design pattern, we will discuss about how to avoid the object communication process complexity. Means in this design pattern, multiple objects want to communicate with each other at the same time. In that case, the object communication become complex. To remove this complexity, mediator design pattern introduced. With the help of this design pattern, we will create a common object. There all the object will share the data and will get the data from that object. For example, some people want to chat with each other. In that case, they will create one group. With the help of group chat, everyone can share the data to the group. At the same time, they can access the data. Observer design pattern. The change of state in one object must be reflected in another object without keeping the object tight coupled. Means we want to notify the object state changing to the another object. In this design pattern, we want to send an update to everyone, so in that case we will use this design pattern and will update all the user by sending the notification. Defines a one-to-many dependency between object, so that when all object changes states, all its dependent will get notified and updated. Scenario is something like that. There is a one object from this websites. All the new users is getting notification whenever any new update is coming on this particular websites. A strategy design pattern. In this design pattern, we have a problems like a problem which have multiple solutions. For example, if I want to search an element from a group of element, in that case there are multiple possible ways to search a particular element. Like we can search that element by traversing one by one element, or we can apply the sorting then we can search. So with the help of this design pattern, we will select the best solution of the particular problem. For example, there is one problem. It have 3 solutions. By applying the algorithm, we will select the best solution for the problem.
Template method design pattern. In this design pattern, we have a problems related to the method calling. Means, if I want to execute any task, in that case, we have to follow some order. For example, if I want to buy a product from a shopping site, in that case, first I have to select the product, then I have to fill the form related to address and all, and then we will go to the payment section. After that, it will get delivered to your address. So here we can't change the procedure. In that case, every steps have one method. So sometimes it will create a problems. In that case, we will implement this template method and will write all the sequence of steps within a method, and by calling one method it will get executed. Example, clients calls a template method. Inside the template method, all the method calling procedures are stored, like method 1, method 2, method 3. Visitor design pattern. This design pattern is used when we want to represent some extra functionality to the existing classes. For example, if we have some classes and we want to add a new functionality to the particular class, in that case it should not affect the previous existing functionality of a particular class. For example, if we want to add a new employee in an employee table, so it must be updated the table, but previously existing employee should not be affected by adding or deleting a new employee from an employee table. For example, visitor added element 1, visitor added element 2, it's added element 3.
Memento design pattern is used to store the previous states of object. For example, if I want to get the previous states in case of text editor, so we are applying the undo operation. With the help of that, we are getting the previous states. But in programs, if I want to track the previous states of object, in that case we have to store that previous states. For example, in case of transaction management, if transaction is successfully completed in both the sides, in that case we will commit that transaction. For that we need both states of transaction, before the transaction states of object states and after transaction object states, and we will compare that. If that is matching with the condition, in that case we will commit that transaction. Null design pattern. In null design pattern, a null object is replaced with the do nothing object. Means instead of putting null object, null value, we have to put do nothing relationship, so that we will not get the null pointer exception. Means this design pattern is introduced to remove null pointer exception. In this case, we are creating one abstract class and we are attaching do nothing object. Scenario is something like this. Client need a abstract object. In that case, there is a one real object and one null object. So we will attach a do nothing with this null object.
Thank you for watching this presentation.